right, now we are going to look at how to multiply radicals. Yesterday you simplified them, which basically did the prime factorization trees and pulled out any perfect squares. Today we're going to multiply them. Now I'm going to show you two ways you can do it. I don't care which way you do it. I personally do the second one because to me it's easier. But again, it's up to you. With multiplying radicals, the first way is you just multiply the radicands, the numbers that are underneath that. So 15 times 10 is going to be the radical of 150. Then what you would do is you just break that down. Well, that would be 15 and 10. That would be 5 and 3. And that would be 5 and 2. Then I would write my big radical sign, and I'd have 2 times 3 times 5 times 5. And then I pull out any perfect squares. Remember, any pair is a perfect square because if you multiply them together, 5 times 5 is 25. The square root of 25 is going to be 5. What's left underneath you multiply together. So I'm going to get 5 times the radical of 6. Now, let me show you what I do. Do you see how when you multiply 15 times 10, you get 150? And then you go back down and you break down the 15 and the 10? Well, skip this step and just break down the 15 and 10 individually. Let me erase this and I'll show you. A lot easier on my whiteboard when I can just clear it. Okay, so look. If I do 5 times 3, I do 5 times 2, and then I go 2 times 3 times 5 times 5, pair of 5s, pull out the 5. So my answer is 5 times the radical of 6. It's just saved me that extra step of having to work with, because sometimes when you multiply these two numbers together, they can be really big. All right, so I'm going to do it this way because to me it's easier. All right, 8. Remember, use perfects. That's 4 and 2, and my 6 is 2 and 3. You go to primes and go down to primes and perfects. So I have 2 times 3 times 4. Now, any pair is a perfect. So I pull out 2 times 2 is 4. Square root of 4 is 2. Pull out the square root of 4, which is 2. And whatever you have on the outside, you multiply together. So 2 times 2 is 4. And I'm left with just the 3 on the inside. All right, let's look at 2 more. All right, 8 times 8. Ooh, big hint, light bulb, light bulb. When they're the same number, the radicand is the same number, just multiply it together. Because what happens when you multiply 8 times 8 and you get 64, what do you get? 8. I could break that down to 4 and 2, and this would be 4 and 2. So I'd have 2 times 2 times 4 times 4. Oops, squiggly. And then that is a pair, so I'd pull out a 2. That's a pair, I'd pull out a 4. 2 times 4 is 8. And when there's nothing, when there's nothing left with the radical sign, you do not do this. Do not put the square root of 0, because what is the square root of 0? 0. And the 0 times 8 would be 0. So don't do that. When it's completely empty underneath the radical sign, that just means the radical sign's gone. So my answer would just be 8. But again, look at the hints. If they're the same number underneath, that's going to be a perfect square. And you basically just pull the number out from underneath the radical sign. All right, 40. I'm going to just do 10 and 4. And then I'm going to do 5 and 2. 35, I'm going to have 7 and 5. Then I'm going to do my big radical sign. Put them in order. 2. And if you need to, scratch them out as you put them down in order so you don't mess up. So I have a 4. I have 2 5s. And then I have a 7. So square root of 4 is 2. Then I have a pair of 5s, which is a 5. And then on the outside, 2 times 5 is 10. And when you're left on the inside, 2 times 7 is 14. So that'd be your answer on that one. Okay. All right. Now, what happens if you have coefficients on the outside? Just one extra step. You multiply the coefficients on the outside together. If you have a negative outside, that's like a negative 1. So you're going to take negative 1 and you're going to multiply it by negative 2, and I'm going to get 2. So what I'm going to do is 2 is going to go outside my big radical sign. Then I'm going to break down 10 to 5 and 2. Now I can't break down 5 because it's prime, so I'm just going to circle it. So I have a 2 times a 5 times a 5. Now I have a pair of 5s because 5 times 5 is 25, so I'm going to pull that out and bring the 5 out. And then what's left underneath is a 2, and that 2 that I multiply the negative 1 and negative 2 by to get 2, I now multiply by 5, which is going to be 10. All right, so let's look at number 6. First thing, let's multiply these together. Those are your coefficients. Negative 8 times negative 6 is going to be 48. So go ahead and put your 48 out front. Ooh, this is going to be a big number. Let me get my calculator ready. Okay. All right, so then let's break down 40. Again, I'm going to do 10 and 4, and then I'm going to do 5 and 2. Sorry, my writing's, this marker's so fat. 32, I'm going to be 8 and 4, just like your teacher's getting, because all I'm doing sitting at home is eating. 4 times 2. Okay, so now this again might be where you want to keep track of what you're putting down. I got 2 2s. Again, just mark them off as you're doing it. I've got 3 4s. Those are 3 4s. And then I have a 5. Does that take care of everything? Yes. So then I have a pair of 2s. So I'll pull a 2 out. I have a pair of 4s. 4 times 4 is 16, so I can pull a 4 out. Square root of 4 is 2. All right, now I'm left with a lonely 5 on the inside, but I need to multiply 48 times 2 times 4 is 8 times 2 is 16, and I get 768. So 768 times the radical of 5 would be the answer for that one. Okay. Of course, next, what happens when you have the variables underneath there? With the multiplying, you're going to do basically the same thing, but this time you're also going to deal with the variables. So 5 and 6, well, 5 I can't break down. 6 is going to be 2 and 3. So let's first do that. So I'm going to draw my big radical sign. I'm going to bring down my 2, my 3, and my 5. Now again, with an x, that just means 1x. X to the third means I have 3 x's. So I'm basically just putting it in expanded form. Well, looking at 2 and 3 and 5, I don't have any perfect squares, but I do have a pair here and a pair here. So that will come out as an x. That will come out as an x. To condense x times x, we're going to say x squared, and then what's left on the inside is going to be 30. So sometimes you might not pull out any numbers. It may just be the variables. All right, now what if we have the letters underneath the radical sign and we have coefficients? All right, first thing, negative 2 times 10. Oops, negative 10 times 2, backwards. Same thing though. Negative 20. So I'm going to go ahead and put the negative 20 out front. I'm going to break this down. Ooh, 4 is perfect. I'm just going to circle it. 12, 4 and 3, prime, perfect. All right, so we have a 3. We have 1 4. We have another 4. I have how many 6s? A's? Gosh, I'm talking backwards. 8 is 6, so that's 1, 2, 3, 4, 5, 6. And then I have one lonely A. So from there, I need to pull out. Well, 4 times 4 is 16. The square root of 16 is going to be 4. I have 1 pair, 2 pairs, 3 pairs of A's. So that's going to be A times A times A. What's left underneath is 3 times A, which is just 3A. Negative 20 times 4 is going to be negative 80. And then instead of going A times A times A, that would be A to the third. So it would be negative A to the third times the square root of 3A. Okay? All right, just a couple more, so make sure you understand them. All right, outside. Ooh, do you all notice something about this? Might have been if I hadn't. My board stuff is not as good as it is at school. All right, let's deal with the coefficients first. 5 times negative 3, that's going to be a negative 15. Do you notice anything about the radicands? 6's are the same. X to the 4's are the same. So everything's going to be perfect. So if you think about it, 6 times 6 is going to be 36. The square root of 36 is going to be 6. I can go ahead and pull that out. X to the 4th times x to the 4th is going to be x to the 8th. The square root of x to the 8th is going to be x to the 4th. If you didn't understand what I did, let me go through it here. 6 is going to be, this will be 2 times 3. This will be 2 times 3. So I have 2 times 2 times 3 times 3. And then I have 4 x's on the first one. And then I have 4 x's on the second one. Okay? So when I pull out the 2 and the 3, what's 2 times 3? 6. I have 1, 2, 3, 4 x's. So you get the x to the 4th. Now look, everything's gone underneath the radical sign, so that means it ends up being a perfect square. Do not put the 0. My answer is going to be negative 15 times 6, which is going to be negative 90, and then x to the 4th. So that's going to be your answer for that one. Last one. All right, negative 8 times negative 6. We're going to start out with negative 48. Go ahead and draw my long one. All right, that's perfect, and that's going to be 4 times 3. So perfect prime. So I'm going to have 3 times 4 times 4. I have 4 A's and 1 B. 1, 2, 3, 4, and 1 B. I have 1 A and 3 B's. Just write everything out in extended form. Then just start circling away. Well, 4 times 4 is 16. The square root of 16 is 4. Let's see how many A pairs we have. We have 1, 2. So that's going to be A squared. Hopefully you get this. I'm condensing this. And then I have a pair of B's. And look, I have another pair of B's. So that's B squared. So what's left underneath is that lonely A and the 3. So I have 3A underneath. Now 48 negative times 4 is going to be negative 192. And then that's going to be 8. I wrote too big. It's going to be negative 192 A squared B squared. And we're left with a lonely 3A underneath. Okay, I hope this helped you out with multiplying radicals.